Dealing with a beam that has uniformly loaded conditions, and sorry, I guess I should go all the way out here. Where does the maximum bending stress occur? Do you remember? The center of the beam. Okay, so when we're talking about our bottom reinforcement, our tensile reinforcement, that's going to have to, here's where we're going to center. Okay? Our development length is this distance, and it's going to be in both directions. Okay? To help develop that strength. That's what we're talking about when we're talking about development length. Okay? Does that make sense to everybody? Okay. We also have to keep in mind, remember we also looked at beams where we had these.
Cantilevers?
Yep, where we had a cantilevered section. And do you remember what happened over the supports? Yep, so we would actually have bending in the top of the beams, right? So here we need to check and see what length do we need to develop over these sections in our top face. Okay, we're looking at reinforcing in the top. Here we're looking at reinforcing in the bottom. Okay? Don't agree?
Well, I agree.
You're just exhausted from it?
Yep.
Here's the thing. We're not going to look at an entire beam.
Kind of hope like, if it's a bridge, I hope it falls apart at this point.
Okay. Okay.
Like that.
The equations that you need for number 6 or smaller. The yield strength of your steel multiplied by the diameter of the bar divided by 25 multiplied by F prime C.
What the hell is LD?
Yeah, what is LD?
Your development length. Sorry.
Length development.
Why do they put the letters backwards?
I don't know why they do that, John. Sorry. This comes out of the code.
Well, I want it fixed. Not doing this.
So your life goals are to actually sit on the board that decides.
They meet twice a year. Meet twice a year. The next meeting is in Las Vegas, so.
I'll be there. I would be
I'm
there.
gonna go there and protest, pick it.
The World of Concrete, is that what it is?
No, ACI.
Oh.
No, the next meeting's this fall.
So it's just a difference of 5.
What was the DB again?
Diameter of your bar.
Got it.
Okay?
What was it?
Diameter.
What'd you add?
He asked what DB stood for. So, yeah, so let's include that. L sub D is development length. D sub B is diameter of bar. Okay? That's all that we have to consider for length, for development length. Okay?
So that's not the D and B from the other problems, that's all different.
Totally new DB.
No. This is D sub B.
Oh, it's a sub B.
Yeah, sorry, it's not two terms. It's D sub B. So your diameter of the bar, remember that comes out of the table on page 400, where it gives you, and remember that when we're talking number 8 and below, diameter of our bar is just that number of the bar divided by 8, right? So our number 6 bar, our diameter of bar is going to be 0.75 inches, right? Number 4 bar is 0.5 inches.
Number 8's 1.
Number 8 is 1. Yep. Cool? Everybody still along for the ride?
I'm still copying.
Willingly or not?
Let's do this.
Still
Okay.
writing.
I gotta go piss later.
That would be awesome.
What page?
No, that's not a sub.
Look how we went
Why
from
is
page
it?
513 back to 400.
What?
Yeah, we're jumping on it.
What? No. This is, just remember, this table is on page 400.
Yeah.
When we talked about reinforced concrete. Yep.
Yeah.
Well, yeah, I can take creative liberty to jump around in the book, can't I? I can do that. And I guess I should say too, for reference in the book, we're on pages 449 to 405,
All right.
452. Okay? So for our problem, we have a cantilevered section of concrete, okay, extending out from some sort of wall column. Okay, I don't know a whole lot about this, other than we have a section coming out of it. You okay?
I'm just trying to picture exactly what that is, drawing the wall.
Looks like a T.
So
Oh.
this could be a wall or it could be a
Vertical
column.
wall.
Yep,
Alright.
yep. So you got a vertical
Good.
wall. Maybe
I
this
was looking
is
at it as like a flat foundation. I got it.
nope. So
Got it. There we go.
we're going down. I don't know how far
Sure.
at this point. Okay. We have to keep in mind we want 2 inches of cover, right, to our formed faces.
Those are formed.
I guess I should say we're assuming we're working with formed faces, right? I'm not assuming that we cast this thing right up into some wall. Probably didn't work out too well with our geometry. Okay? So what we'll find is that based on these stresses, based on how these things are going to work, we're going to have 2 development lengths. Okay, we're going to have our development length within our wall. We're going to have our development length outside in the cantilever section. Okay? And so the first thing we'll do is, well, no, I'm sorry. The first thing we need to do is set up some parameters. We're using number 6 bar. Okay?
We don't got time for
I
this.
know the formula.
So dB equals 0.750 inches. We're using 3,000 PSI concrete. And we're using 60 KSI steel.
There you go.
Okay? So what is our development length that we need? Which equation are we going to use?
First one.
We're going to use the top one. Okay? So I'll use the top one. Put in 25. Okay? Crank through on this guy, it actually comes out to be 32.857 or something, but 33 inches essentially. Okay?
For the whole thing? Or just the top?
That's what we need for our development length. Okay, that's what our LD calculates out
Oh,
to be.
that whole, okay. You need
Okay.
a complete answer.
Yep. We now also know L1, so the dimension from the wall to the end of our cantilevered section is 48 inches. And L2, okay, even though I draw this very poorly to scale, equals 36 inches.
So that's provided.
It's provided, yep,
Okay.
yep, it's nothing that you have to determine on your own. Okay?
So what would be?
There's one last thing that we have to take into account. When we're dealing with our bottom steel, our development length that we calculate out of this equation, we can go ahead and use that, okay? If we're dealing with top steel, and we have more than 12 inches of concrete underneath, we have to multiply it by 1.3, okay? While we don't know this dimension, we're going to assume that that's what we need, okay? So if you take this number, multiply it by 1.3, it gives you 43 inches, okay? So now,
So you said the 1.3 is if you have more than 12 inches of concrete?
if we have more than 12 inches of concrete below that.
Below.
Just for the purposes of this example, we'll assume oops, off the board there, I'm sorry. Assume that it equals 14 inches, right? Whatever it is, so that we need to use this number. Okay? So when we're considering this cantilevered section, what's available to us as a development length? What would it have to be?
48 inches.
Minus, what do we have to subtract?
43 inches.
L2.
We have to subtract our cover, right?
Oh,
We have to have that distance between our steel and the face of the concrete, okay? So that we have space so that it can pick up some moisture.
do I wanna ask the question where you got 1.3 from?
No.
It's a given.
It's a given number that lots of engineers got together and figured out as a consensus.
It's a
That's what they
constant.
need to use. It's a constant value. Anytime this dimension is greater than 12 inches or greater, John, you just multiply it by 1.3. Okay? It's not a scaling factor. It doesn't
We're assuming
increase.
it's 14.
Yep. Okay, so your available length for this cantilevered section would be your 48 inches minus 2 inches, so you have 46 inches available to you. No?
How do you?
So what? What does the 33
Oh, there we go.
tell you?
Sorry.
For real.
We'll get there. We'll get there.
We're not there yet?
So 33 is for the bottom and 43 is on top.
Mm-hmm.
6 will fit in both then? Or we gotta have bigger on the bottom?
Just hold on. We're just looking out here right now. Okay?
They're nice.
I suppose.
Okay, so we need 43 inches. We have 46 inches available to us. Okay?
Beautiful.
So steel works. Within the wall itself, this is not our top concrete, right? We don't have this scenario,
No.
so it defaults to this selection, okay? So here we don't need to multiply it by 1.3, okay?
Okay, and L2 is 36, so we got another.
36 minus 2 is 34, and you need 43.
About that time, Ben.
The last thing that I just needed to tell you is these values, okay? I showed this to you once so you understand where the calculation comes from. You can find it on
Oh, that's horse.
Table,
table 13.9, okay?
do you have a page number now?
451, I think.
Somewhere between 449 and 452.
Yep.
So then, 34 doesn't work.
No, 34 does work, because it's not top bar at that point. It has concrete over the top. Okay?
Are you gonna post homework today?
I'll get homework posted for you tonight. There'll be 2 problems just like this, okay? Remember, I showed you how to calculate this, right? So that you know it, where it comes from. These values are in the table. It gives you values for 3,000 and 4,000 PSI concrete. It gives you values for 40 KSI and 60 KSI steel, okay? So there'll be 2 problems like what we did at the end, 1 problem like the continuation on the footing design. Cool?